Thank you. Thank you. Thank you for your kind words and your introduction. I'm really pleased to be here addressing you people. And I'm very passionate about precast technology and precast construction as such. And I've been here for about last 11, 12 years with Animatic, uh, getting engaged with various stakeholders of the industries. And the journey has been very eventful and exciting. So today I've been called upon to speak a little bit about the machineries and the plant and equipment that is related to precast, which is also a very important part of the entire story. Like, precast has got three major, I would say, uh, important triangular, events which require proper coordination. One is your architect and structural design on the knowledge partner, and then you have the plant and machinery supplier and the plant itself as the cornerstone of producing the right elements, and then you have the contractor and execution partners as the delivering project team. So these three play a very important and key role. And I'm today going to talk a little bit more about precast technology, what all equipments are involved in producing different elements, and what is the consideration with which you start choosing and why you have to choose a certain uh, equipment rather than the other. Right? Let me just present you my screen, and I think we can go ahead with this. Just give me a second. Tell me once you are able to see the screen. Sorry. Thank you. So I made this presentation for this particular session, and it talks about what are the consideration for a selection of a precast plant. As you understand that precast construction starts with uh, the architectural layout of a building, whether it is residential, commercial or industrial building. Uh, once the architectural layout is freezed, then the structural engineer comes into picture, and then he defines. Yeah, yeah. Okay. Yes. Okay. So, oh, the shape is kind of, yeah. Are you able to see the full screen now? Okay. So, uh, starting with what, who is Alimatic? Alimatic is a company from Finland, and they were established in 1959. After the Second World War, the entire Europe had to restart building after all the damages that were created out of the Second World War. It was no different in Finland as well. And they had a large amount of a migration of people towards the cities, which is what is happening in India right now. That there is a huge migration of people towards the cities, and that created shortage. And plus, Finland had to pay a lot of reparations to the US and other allies, as Finland had to fight the war, and that made them understand that they have to quickly make the residential apartments possible, industrial buildings possible. And Finland, with 6 months of snow and darkness, had to invent precast technology. Some of the elements which I'm going to talk about is Finnish patent technology, like hollow core slab is a Nordic country contribution to precast technology, and that's patented by Finland. Many of the technologies related to production of hollow core slab. So in 1974, the Finnish government passed a rule saying that they're going to standardize the use of precast in all the buildings. So once the standardization was set, then the thickness of the walls, the kind of insulation that was to be used for for the facade walls, the spans on the buildings, the column sizes, they're all defined very well in the document that they had. And because of this standardization, Finland went very well ahead with industrialization of manufacturing of buildings. So, our B.G. Shirke was talking about in the 1970s. B.G. Shirke, as you know, is our famous industrialist from Pune, who adopted prefabrication much earlier than anybody else in the country. And he was to tell that we have to have industrialization of civil engineering. Otherwise, we are going to have a lot of problems by having site-based construction. So I think his dream is also coming true now, because Shirke is doing a lot of precast buildings all over the country. Similarly, in Finland, this happened. And then in Finland, it is like this, that precast industry is a building material industry, unlike in India, where it is a contract-driven industry in India. Whereas in Finland, you can buy a precast element from a factory by giving the drawings of what you want. So coming to this, this small country of Finland has delivered more than 4,000 plants. It's an export-oriented economy. And India has been also one of the key markets. The second factory of manufacturing is set up in India itself. So you can understand the importance which they have given to India. This was somewhere in 2012, they have established this factory. And of course, that has paid dividends to them now, because now the pace of adoption of precast in India is also going up. So these are the steps for, let's say, construction of precast plant and support. There is an engineering and design part of it to understand the buildings. And then based on the elements that are required in that building, supply of machinery. This machinery is flexible to address all the requirements that come about in a building, whether it is commercial, industrial, or residential. Then we also do turnkey installation and maintenance of the plant. And then finally, precast element installation, which is making the structure possible. So end-to-end support is required when you have a technology being adopted. So what are all the elements that are required for doing a building? There are 5 structural elements, which is, one is a slab, then you have walls, then you have columns, beams, and then staircases. These are the 5 major elements, and depending on what kind of building it is and what kind of combination you are going to do, that will determine the size of the plant, the amount of production requirement, and the kind of automation that is required. So you can see here that there is an element called a pre-stressed hollow core slab. These are 1.2 meter width and long line produced elements, and these are like very, very efficient kind of slabs that can be used in any kind of building. Then you have regular reinforced room size slab. We call this as a deck slab in sometimes, or half slabs, or even filigrane slabs. So reinforced room size slabs, and then filigrane slabs, half slabs, lattice girder slabs, all of them relate to the similar kind of structure. Usually it spans about 4 meters, whereas pre-stressed hollow core slabs span between 6 meters to 20 meters column free space. Then you have load bearing walls. We also call them as shear walls. Then we have facade walls in that. And then there is columns. There is a single columns that is only going up to 1 floor. Then multi-story columns, depending on where is the application. In industrial buildings, quite possibly we have multi-story columns used. Then you have beams. We have normal beams for industrial buildings, and then for commercial buildings we have pre-stressed beams where it is supporting slabs. And then you have staircases which are made with flames. So these are all the different elements that are made in a precast factory. So I just thought that it is better to have a precast factory layout that gives you an idea about what actually happens in a precast factory. So here, this area is the batching plant area. Are you able to see my screen? Virender? Hello? Ah, okay. Okay, done. All right, okay. So here is the batching plant area. And you know that batching plant requires aggregate. So aggregate storage raw material will be somewhere here. And in a precast plant, usually anything between 20 mm and down aggregates are being used. Hollow core requires something like 16 mm and down. And rest of the column, beam, wall production requires something like 20 mm and down. And here you can see the first hall is the production hall. So this is your raw material storage and concrete production area. Second part is the production hall. This is a long line hall, like about 200 meter in length and 100 meter in width. So this is the kind of a plant area under the shed. Then you have at the other end, perpendicular to the production halls is the stockyard area, where you're going to put all the elements. So why the hall is perpendicular here is because the cranes are running, the EOT cranes are running on this 2 bays or 3 bays, depending on what is the stockyard number of days of storage that is required. And then the element is transported through a wagon directly into the stockyard. You can see this wagon rails which are coming here. It goes directly into the stockyard. And then the cranes will pick up this element and place it efficiently in any of these areas. Usually we would try to stock it just in front of the stockyard, but always it is not possible to have so much of space here. So it might get moved to the other end of the stockyard as well. The trucks will come from outside and come into the stockyard, come in this area, pick it up and then come out and go back into the roads or transportation mechanism. So the logistic is happening that way, that the truck will come to this end of the hall and deliver raw material here. And then the truck will come in the stockyard area, pick up the material and get out. There is no movement of trucks inside the precast yard. We believe that if you are having movement of truck inside the stockyard, either you should have a very low production, or if it is a reasonably large production, it will create a lot of bottlenecks when you have trucks moving into the stockyard, production yard. So in the production yard, we are providing transportation wagons to move out the material which is produced and cured already on this transportation wagon, which goes directly into the stockyard, as you can see here and here and also here. There are 3. One for, this is the slab production area, which you call as the hall 1, where you are producing pre-stressed hollow core slabs. And these elements that you can see here, here is a concrete distribution system. I will show you what that means. There is a transportation track for the shuttle, which comes on this track and then delivers the concrete to this distribution. And that distributor is going to pour. These are all aerially mounted, like, it is not in the floor. It is on the height of about 4.5 meters from the ground. And these are your EOT cranes. Here also you can see the EOT cranes, and these are the tables on which your wall elements are being produced. And there is a small stockyard here to do some kind of a repair or whatever you need to do. And this transportation wagon is taking the walls directly over. So you can see a better picture here. Like you can see these long lines. These are slab production. These are in the length of about 120 to 150 meter. And here is the batching plant, and this is the stockyard area. So you have this column and line, beam. This is a hollow core slab line. And then you have column and beam line production. These are also long line production areas. And then you have wall production. So this is a kind of a small schematic of how this precast plant will look like. You can see 3 bays of 20 meters of 150 meter, storage space of 24 into 100. That means 24, each bay is 24 and the length is 100. And there might be one or multiple bays depending on what is your requirement of storage. Usually storage goes from 7 days to almost like 30 days of storage, depending on your how fast you are able to move the stockyard out into the building for construction. So you can see from this particular thing, we divide the plant into one is your daily casting and the casting in 2 days. When you make columns and beams, these are massive concrete elements. Usually in a commercial building, it goes from 1.2 meter into 1.2 meter size of the columns. So when you have that kind of size of the column, it requires 2 days to gain the strength that they can be stripped from the production yard. So here, when we talk about production capacity, it is the capacity of the plant to produce on a per day basis. Let us say, for example, pre-stressed hollow core slabs, we are having production quantity in this particular thing. We are talking about a 3-line bed. So here, if you see, this is 3 lines of 120 meter. So when you're talking about 3 lines of 120 meter, every day you're able to produce 360 square meters of slab. So that means like almost 1,08,000 square meter or almost 1 million square feet in every year That is about a 300 days working. And then you have column molds. Each mold, like you can see here, the length of the mold, it is about 108 meter in this particular line, and 100 meter. There are two lines of columns. So we are talking about 216 meter of column. And if you look at the production here, it is about 180 meter. Why it is 180 meter? This is because casting happens once in 2 days. This is the 2-day cycle. So a 216 meter of mold will produce 180 meter of column every day. Beam mold similarly, casting once in 2 days, also becomes similar. And then load bearing walls, casting happens every day. So you're talking about, let's say here, you're talking about a 15 table KVT is a technology, and we are talking about 10 by 4 tables. 10 by 4 means 10 meter length and 4 meter width kind of a table. So each table will produce 28 square meter. So if I take here, it is about 520 square meter, because here there are also other type of tables in this, involved in this. If you look at the layout, there are also 3 separate tables of hydraulic tilting used for shear walls. So you got the general idea of how a plant capacity is determined. So approximate manpower required to operate such plant is 100 numbers. Most of the manpower is mainly used in column, beam, and wall sections, because there is a lot of reinforcement cages required here, and a lot of coordination in terms of MEP and inserts required in column, beam, and walls. The reason is also because that India is a seismic country, and we need to have a lot of reinforcement, making sure that seismicity is addressed in each of the structure that we make. Most of these precast structures are supposed to be monolithic and follow the codes for which will behave according to a cast in situ building as per the codes of IS. So you can see here the capacity of the plant. Like if I take beds, then it is 342. Future, the expansion is possible in those beds of the hollow core slab, and similarly walls will have, and columns will have. So look at the machine here. This is an extruder. An extruder is a machine which will produce a hollow core slab. The slabs are shown on the left hand side, and it is able to remove the concrete from the neutral axis, allowing only the webs where the pre-stressing strands are there to carry the load of the slab on the slab. But these concrete elements are highly compacted, and it is using M50 to M55 grade of concrete, and it is a very dry and lean concrete with a water cement ratio of 0.3 to 0.33. And when this goes through the machine is able to compact it both by extrusion action as well as the vibration action and a shear compaction action within this module, such that without any form, basically there is no shutter for it. The hollow core slab is produced just like that on the table, on the bed, and immediately after production, you are able to stand on top of the hollow core slab. So that is the kind of compaction we are talking about here. And you can see here that there is a starter plate here, and there are strands running. These strands are the pre-stress strands, which are pulled, elongated by pre-stressing. At the other end, there is an abutment which is used for doing the pre-stressing, and that pre-stress strands are positioned such that it is placed in the web, within the web. And you can see it is produced on a long line, and then it is cut to span. This is your hollow core slab production hall. This is the shuttle which I was talking about, bringing concrete from the batching plant. And then you can see at the far end, there is a distribution system, which is actually doing the concreting to the bed. You can see here the distributor. The distributor is just above the extrusion machine. That shuttle will bring the concrete on the track. This distribution hopper will go to the end of the track and receive the concrete, comes back and pours into the machine. The machine is moving on the bed, and this seamlessly follows this machine and keeps on feeding it with the concrete. I will show you the video. And then once the production is over, you are removing that production from the bed and placing it on a wagon. Now this wagon is of a particular length. It is coming in pairs, and this whole stack is moved into the stockyard. And once in stockyard, after 3 days, then you will take it out using a crane and load it onto the truck. And now this truck is ready to go to the site. And once it moves from the production hall or the factory, there is no storage of these slabs anywhere. It has to directly go into the building. If you are an efficient user of precast and if you want efficiency in manufacturing and erection, then there is no second handling of these elements once it is on the truck. The truck goes to the site and it is directly pulled on by the tower crane at site and placed it on the building wherever it is required. The next ones are the frame elements of a building, which are like precast columns and beams. Columns are vertical members using only reinforcement, and they have corbels. Depending on the project requirement, there can be 2 corbels, 3 corbels, or 4 corbels. So we can produce all types of columns in the factory, but preferably the 4th corbel is always produced in the stockyard to maintain the flexibility in the mold. Because if I provide a negative corbel on the 4th side on the floor of the bed, then that mold can be only used for that particular column size. For that reason, most of the factories do not produce the 4th corbel in the factory. It is produced in the stockyard by leaving some reinforcement, bent reinforcement ready, and then you make a secondary casting in the stockyard to produce the 4th corbel. You have also this beams. Either it could be a pre-stressed beam or a solid precast beam. Most of the industrial buildings do not require pre-stressing because they do not carry much load. Whereas in commercial buildings, we have this kind of beams having pre-stressing tendons plus reinforcement. Many of the projections are there for reinforcement. This will be merged with the slab when you do the site concreting. You should remember that no precast building is 100% prefabricated only. There is going to be wet works. About 15 to 20% of the work is wet work. That means we are going to place the slab on this junction. For example, this is the inverted T beam. The slab will come here. There will be a lot of reinforcement on top, and then we are going to pour structural concrete on top of this so that the slab and the beam all become monolithic elements. And here you can see the precast staircase. Staircases are coming as a single element here, and landing is provided here. So landing has got grooves to receive the staircase, and then it is drilled or fitted together and then again grouted as well. These are pre-stressed beams production. This green, yellow, and red element, what you can see here, is the abutment. These abutments carry a force of about 750 ton, and these abutments are carrying these forces to the bottom on the foundation, and that is a steel plate going equally down, plus bolted and welded to the foundation, so that when you are pulling these strands, there is a 750 tons of force being used when you are pre-stressing this, and that requires to be taken care by the foundation which is there. And you can see here how the beam molds are. These are called side shutters. These are flexible shutters that can move left and right, which means to say I can produce a beam of 800 mm width or 1.2 meter width, depending on what is either in the drawing, by just moving the shutters left and right. 600 mm of moving both, 600 mm both sides are possible, like no, 600 mm here, 600 mm here. So we are talking about a play of about 1.2 meter in the beam mold or even in the column mold. And then you have this staircase mold. The staircase mold is like a book. It has got a central, stationary partition, and both sides are opening or closing. We have sizes from 1.3 meter width to 2.4 meter width, and the length is, we can have variable length starting from 3.7 meter length to 4.5 meter length in the staircase. And the staircase tread and risers are fixed, usually 250 or 300 tread and 150 mm riser. And you can see here the wall production system. The wall production system has got a concrete casting on the table, and you can see in the picture here that you have different elements casted here. These are 2 solid walls. This is 2 window openings, and here is a solid wall, which is a long wall. And then you have here door and windows. Window here, some of them are showing only reinforcement, right? So this is the complete series of tables, on top of which there is a casting machine, and then there is something called a wagon if we are talking about a semi-automated system, and sometimes we are only having mechanical tinting as well. So Walls are produced on the table using aluminum shuttering and magnet that help you to produce different elements with different sizes. Walls can be 4.5 meter by 3 meter or 3.3 meter height and 4 meter, or even sometimes having 6 meter long walls. And these are the formwork and magnets used for making windows, doors. These are flexible formats which allow you to, not to weld the table, not to drill the table, but hold these forms using the magnets. Magnets have got a force of about 1600 kgs pushing on the table so that no slurry leakage will happen. Plus, these forms give you the right angles that is required for producing a precise wall. So you can see here after production, we are lifting lifting the table out so that extra forces do not apply to the wall. And once it is tilted by about 80 degrees, you pull out the wall from the top using hooks by using a EOT crane. And then it is taken through the wagon to the stockyard and cured also vertically. Walls always get transported also vertically, only produced horizontally. Now, if you see the construction site, this is your excavation. Then you are laying the reinforcement and putting the PCC, and now your plinth beam is ready to receive the walls. And here the walls come through truck, and then you lift the walls and place it on the reinforcement rebar. And you can see these holes here, which are the grout holes allowed. There are sleeves or grout couplers here. So this becomes a monolithic joint. And these jacks are used for doing the alignment of the wall. And then you have the slab. Sometimes whenever you require coring on the slabs, it is preferable that you plan it out in the factory itself. If not, you can always do the coring at the site. And the slabs are placed one after the other. Each slab is 1.2 meter. On top of that, you are going to put a nominal reinforcement 8 mm. You are going to pass all the conduits like this, and then you are going to make the screeding. The structural screed becomes an integral part of this requirement of hollow core slab or any kind of slab, so that it has a diaphragm effect and holds all the elements together. Now you can see here, with a good design, even balconies are becoming part of the wall. We are not having it as a 3D element. So this is just an extension of the wall, and on top of this are going to be placed the hollow core slabs, which will become then the part of this balcony structure. You can see the slabs lying around here, and also you can see the number of people in this site. This is an ongoing site. Maybe maximum about 7 to 80 people are working on this entire site of G+5 building, and it is a pretty fast construction of this building. This is about 1 lakh square feet. This 1 lakh square feet building, they are able to produce and construct, including the foundation, in about 2 to 3 months time. So which I think is quite fast. And precast is not limited to only gray buildings like you see here. You can have these kind of patterns. These are something called graphic concrete, which are etched concrete. And then you also have different kinds of rectally molds, which are PU liners, which ask you to produce different kinds of patterns that you want on the wall. So coming back to what all can you produce in a factory? You can produce a sandwich wall panel, cladding panels, solid slabs, Ecotech panels, extruded hollow core slabs here again, ribbed slabs, slip form T-beams. So the variety is endless. So this is our market area. And coming to again back to the services that are required for doing a precast construction are all listed here. I think in your workshop you would have already reached out to some of them. So what I will now play is just the video for you to have a look at how the hollow core slabs are being made. Just give me a second, please. This is the video for production of hollow core slabs. This is a very important video because these are like highly automated production systems which allow you to produce high volume of slabs. About 1,000 square meters of wall slabs are produced every day in this factory. This is the maximum capacity of one factory. So you can see the batching plant starting with this. And you see the consistency of the concrete, which is showing you now. So this is a very, very dry concrete, very low moisture content. And then first operation is to clean the bed. The beds are steel beds laid on the concrete foundation. These are long line beds, about 150-meter long. And then you also can see the strands. This machine is going to place the strands as well, pull the strands, clean the beds. This is called a preparer machine. So it prepares the bed. So the strands come in coils. It could be of diameter 9.2 mm, 10.7, 11, 12. So in this variation, depending on application, the structural engineer will decide what kind of diameters to be used. And they are then stressed. So you can see that the wires are going to be now stretched. They are locking the beams onto the abutments, and the strands are passed through, held by wedges at the end. You can see the wedges here. Those are holding the strands in position. And now we are going to pull the entire beam so that all the strands are getting stressed in the single time. We also have machines for single stressing as well, but this is a multi-stressing machine. So you can see all the strands are being stretched. About 15 centimeters of stretching goes on. You're talking about a 300 tons of pressure being applied here on the strands. So why pre-stressing is to transfer the stressing force into the concrete so that it becomes better in tension. Then you have the hollow core slab machine. This is called an extruder. Now this extruder is the heart of the entire precast hollow core slab production. And concrete transportation, receiving concrete aerially by a shuttle. This is called a shuttle or a bullet, whatever you call it. It's a container containing about 2 cubic meter to 3 cubic meter of concrete, depending on what is the size you are looking at. This goes on the track, goes to the hall where the distribution is doing its work. The distributor, it transfers to the distributor hopper, and it goes back to the batching plant to bring the concrete. The shuttle is very fast. It moves at around 2 meters per second. So now you can see the distributor following the extruder and pouring that into the hopper of the extruder. So this is entirely automatic production. Maximum 15 people are required even in Indian condition to run this entire operation, including batching plant operator, stockyard operator, because all these operations are automatic. The shuttle movement, the distributor movement. So you can see the casting of the hollow core slab. Without the form, a very hard kind of a slab is being produced of thickness, anything between 150 mm to 500 mm, depending on the span and load. See, this operation is automatic. The shuttle, the distributor, and the extruder machine are in communication with each other. So they continuously know where their positions are. So the casting machine and the extruder do not wait for each other. They come and interference. It comes and searches for itself and then pours the concrete onto it. And shuttle knows where this distributor machine is available in the hall. So it can go anywhere where the distributor is. So now this casting is over. After that, what we do is modify the slab. That means if you have small openings, this here shown is a automatic machine that does that. In European conditions, they do not want to hire more labor. Whereas in India, we do these openings through labor force only. We do not use automatic machines for this operation. And we have something called a maturity controller, an automatic system which measures the maturity of concrete. And under these beds are hot water pipes. They are allowing a continuous circulation of hot water and maintaining the temperature of concrete between 45 to 55 degrees centigrade. And depending on the amount of time that this circulation happens, maturity of the concrete is measured and it becomes again an automatic operation. At the back end, we have this testing of the cube, whatever is required to be done, but at least the operations will not stop. The alarm is given by this system so that it is easy for the people to maintain an automatic operation. So you can see the cutting now. This is the saw machine. It has got a laser marking, and then it will use the saw to cut the slab. This is the 360-degree angle saw, and it can turn around to cut it at angles. You can have a horizontal cut, you can have a vertical cut, you can have an angle cut. So the saw machine is capable of doing cutting of the slab because the span has to be maintained depending on the design. So it is produced on a 150-meter long bed, and then you are cutting the slab. Now you can see the finished slab is ready, being lifted out of the bed as it is cured and ready to go. Now this is a one-day operation. This slab is a one-day operation in the factory. After that, it goes out into the stockyard. Here they are drilling some holes at the bottom because in Finland there is a lot of cold, and sometimes the snow will be formed inside the holes of the cores of the slab, and they don't want it to be there when they are making the erection of this in the building. So holes are allowing the water to thaw out and get out of the slab. So now they are placing this onto a transportation wagon, taking it out into the stockyard. It is stocked in the stockyard, one above the other. Usually 4 to 5 slabs are stacked one above the other, waiting for the next movement onto a truck. So from the factory, once the quality control gives okay, then we are moving this material directly to the site. There is usually a small test laboratory inside the factory where you do all the testing that is required, maintain the certificates, and then it goes directly to the stock. Construction site. Construction site has got a tower crane. Tower crane lifts the slab and then it places this onto the slab area, either on the beam or the wall slab. Here is the residential segment, so it is wall frame. If it was commercial building, it would have been column and beam. Beam would receive that. And usually you can keep about 8 to 10 slabs in 1 hour. So you can imagine the speed at which it can be placed. And also it does not require any kind of propping or support or scaffolding. So you can start the finishing immediately below the factory. I'll play one more small video for wall production. This is also a very interesting video. You can see the wall production on a large scale. This is again an automatic factory. I wanted to bring it to your attention saying that in India, we do not use any sandwich wall, but in the Middle East and European countries, sandwich wall is very extensively used. What do you mean by the sandwich wall? The outside wall, which is facing the outside, is a facade wall, and the inside wall is a load-bearing wall, and in between that, you have a sandwich, which is what is called the EPS panel has been placed inside, so that you maintain a very perfect insulation for your building, whether it is a residential or an office building. With this kind of insulation, you are able to save a lot of energy. The energy leakage to the outside is minimal when you are using sandwich wall elements. So I can now show you how it is made. So these are all automatic bar cutting and bending machines. And there are also automatic cage making machines. When you're having a large volume of wall to be produced, cages can be fed automatically through beam tekla, and then the cage is formed. So now this cage is lifted and placed onto the table, This is the table assembly which is being get ready. We're cleaning and oiling the table. And you can see shuttering is already placed with the magnets for the windows. And then you place the first layer of wire mesh. This is for the facade wall. This is a single layer. So the concrete shuttle is coming here, transporting concrete to the distribution system. And then first layer of concrete is poured here. This is for your facade wall. And once the vibration is done, then you place the insulation element, which is the EPS panel. Now you see they are placing the second layer of much stronger reinforcement, because this is a load bearing wall. And then you tie your second layer to the first layer through that lattice girder in between. Then you pour the second layer, and then you again compact the entire thing, finish it. Then you cover it with a sheet for curing. Now you have a curing chamber here, because this is an automatic kind of a system. The curing chamber, then it remains there for about 10 to 12 hours. After that, the table comes out of the curing chamber, and now it is already cured and ready to be lifted out from the table. You remove the shuttering, and you can see there the insulation panel just projecting out of the load bearing wall at the end. You tilt the table, and you can also see reinforcement projecting outside from the top to receive the next wall. So these are perfectly insulated walls going to the site. These are the transport wagons taking that into the stockyard. In the stockyard, you stock all of these walls. You have barcode on each wall, which tells you by scanning it where this each element is going to go. So this is an industrialized construction, my friends, in its real sense. This is manufacturing. So all the principles of manufacturing are applied here: quality control, sequencing, production planning, and site erection planning. And it is all followed by using a software system which keeps a track of each and every element, where it is produced, where it is lying in the stockyard, and how it is going to be erected at what point, in which building. This was a mega project done in one city called Bismaya city in Iraq. The last presentation I want to show you is about an internal partition wall, where we are talking about this technology being used for replacement of block and brick walls. This is a example video of a company called ICC in Sri Lanka, who are using this technology to make internal partition wall for a building. So you can see here how the walls are coming into the internal partition places, and then instead of block and brick, how they use this to do a very efficient construction of internal walls. So these walls are coming in bundles of 5. All of them are hollow core again, and have a tongue and groove joints. Each wall is 2 feet in width and 3.3 meter, up to 3.3 meter in length, depending on what your slab to slabs distance is. You can go from 2.7 to 3.3 meter. So you can see here the whole bundle of about 1 ton is lifted and placed on the slab, and then using pallet trucks, move that entire bundle wherever you want, and then distribute these panels according to the placement. And you have a hydraulic wagon which will lift and tilt these walls and give it to you for production. You'll see now how they tilt it. This is the grout material getting ready. So you start with one end of the wall or the column, and then each wall is placed one after the other. This whole wall can have thickness anything between 75 to 120 mm or even 140 mm thickness. And then you toggle it and fix it. Bottom there is a mortar. On the top there is a gap which is filled with the PU foam. On left and right side you have this tongue and groove. That small V section is drilled in for stability in the beam, but it is not connecting the top wall because it's a non-load bearing wall. So you do not want any kind of sagging of the beam or the slab to put load on this wall and create a crack. So you're just keeping a insulation layer in between just to fill it up and give it a bit of a space there for taking care of the expansions and sagging. Now you can see the comparison between CLC wall being on the left side and the Ecotech walls here. It is 7 times faster because the right side wall of Ecotech does not need plastering. The left hand side is finished to only half the extent, but still they need plastering here. Whereas the wall here, Ecotech, does not need any plastering, and that's about 7 times faster. So this, in Hyderabad, we have 2 companies doing this Ecotech walls. Robomatic and Volotech. Then you can cut open, you can chase the wall, and you only need putty and paint after this. What we know is that it is about 15 to 20% cheaper compared to block and brick walls. Just because that you don't need much of labor, and second, it is very, very fast, and third, you don't need any plastic. So these are the things I wanted to talk to you about. Gentlemen, if you have any questions, I'm here to answer them. Thank you. Thank you. I hope it was useful to you guys. Thank you very much for the patient listening, and I hope that it was of some use to you in your session so that you get a better understanding of the entire ecosystem, the Precast. See you guys. Thank you.